Welcome to Professor Russell Esposito's channel on information security. This video is just one of many video modules that are part of Professor Esposito's course on the subject. Video modules for his entire information security course are located on this channel. So remember to hit the like button as well as subscribe if you enjoy the video. Thank you for watching.
Planning for incidents. How do you manage those, and business continuity, whether you have an IT disaster or a broader disaster in your company that you need to plan for. That's what this module will be covering. In this lesson, we'll look at some calculations for preventive maintenance, looking at durations, duration of time between failures, etc., and some financial calculations, or simple calculations really. We'll look at some really interesting RAID storage technology that allows for a quick recovery. We'll talk about incident management planning, risk assessments, IT disaster recovery, how to recover from, how do you plan for a total disaster in your data center that cannot be recovered, in hours and takes days or weeks perhaps. And then we'll look at business continuity, which is broader than IT disasters. This is really any disaster in the company. How do you plan for that? It's not really specifically an IT function, but often IT will be responsible for it because IT is familiar with the data center disaster recovery planning, the IT disaster recovery. So there's some connection between that and planning for any disaster. It may not be a computer disaster. It might be a building. Maybe your computers are running, but the building is quarantined, or there's a fire. There was a fire, and the fire marshals have closed it. And then we'll talk about some forensics, but we'll follow that up with a more detailed chapter and module on forensics. Preventive maintenance in IT is very important, and there are some measurements that are commonly used. The first is mean time to repair. So how long does it take, and how can you minimize this time for a failure like your internet provider? Your ISP failed, and you switch to a backup ISP. Most companies will have two internet service providers, ISP, because it's so critical if one fails. So you should look at what are the procedures for that, what's the mean time to restore. The next one is mean time between failures. How often does this happen? Does this happen frequently? Maybe you need to replace your ISP, or if your email outages happen frequently. What are the mean time between failures? So again, it's a measurement to see if something needs to be remediated, modified, or perhaps replaced. Which really leads us to maybe the next one, mean time to total failure. What's the lifetime of the product? Most of the times, total failure relates to a failure of equipment. What's the lifetime to refresh your equipment, refresh your laptops, your servers, your desktops? But there will be ultimately a replacement of key software also. It may not fail completely, but it may fail to meet your expectations, or may fail to meet the needs of the company. And at some point, you need to replace your software as well if it's a key application. So those are the three measurements: mean time to repair. How long does it take to repair a problem, an outage? How often does this happen between failures, MTBF? And the last one is, if you're having equipment generally may not fail, but you may want to refresh it if it's 3, 4, 5 years old before it fails a lot. But you have to sort of look at the lifetime of a product. You may want to replace it if it's 4 or 5 years old and it's a critical component in your infrastructure, or you may want to replace a key piece of application software if it's failing to meet the needs of the company. So those are the three sort of measurements of equipment and software, and sort of maintaining them and keeping track of these metrics, so you sort of understand, what your risks are, and you have a plan for replacing and improving your repair record, your response time. So this slide really covers what the cost of certain disruptions. So the ARO is the annualized rate of occurrence. How often does this happen a year? What's the likelihood that this will happen in a year? Once, twice, 3 times? Whether it's a laptop stolen, or some damage, or some problem with if your web server goes down, it's key to sales and it's down, once or twice a year, you need to measure that and look to see what the cost is. So how often does it happen is the first measurement, the ARO. How often does it happen within a given year? The second one is what's the loss? What do you expect to lose? So if your web server is down twice a year, for 24 hours, or not 24, maybe an hour or two, hopefully not 24 hours. What's the cost per hour? Or if a laptop's stolen, again, how often does it happen per year, and what's the loss per laptop? So whether it's a service that's out that causes a disruption and maybe financial loss in terms of sales, or whether it's equipment that's stolen or damaged or destroyed somehow accidentally, what's the cost of replacing that? And then the final one is just a simple multiplication. How often does it happen a year? Once or twice a year? What's the cost for this event? So if it happens you have 7 laptops stolen a year or lost, and they're $1,000 each, it's $7,000 is the ALE. I like to think of ale as ale, like beer, because that's the final product. So that ALE is your final product. These are calculations, and the previous slide also that you might find on the Security Plus exam as well. But these are fairly standard concepts that are used in IT for just managing the department and ensuring that you're replacing equipment, or you're looking at what the cost is to manage the more expensive costs, within your infrastructure, and improving on response time, or improving on understanding what your budget will be when you look at these annual cost disruptions. Budget for whichever department is impacted by this loss. It might be IT. If you're losing laptops, it might be the sales department if your web server is down a few times a year for a few hours. So it depends on the department, but there needs to be some understanding in terms of budgetary impact. There are some interesting techniques to provide high availability of your disk storage, of your storage arrays. And there are more than these 3, but these are the 3 most common technologies and techniques. So they're called RAID, and there's a definition for RAIDs on the bottom of the screen of the slide: redundant array of independent disks. So essentially these 3 we'll talk about. These are the common ones. Let's look at the top right hand corner, RAID 1, which is mirroring. So let's say the first blue stack of blocks in your drive is an important disk array, and you want it to be available all the time. It'll cost you double the amount of storage space, but you could double it, you could mirror it. So if you need 1 rack of 4 blocks, now you pay for another 4 blocks, 8. So it doubles the cost, but it does give you some tolerance in terms of if one of these blocks is lost, some drive fails, you have the other array on the right hand side here. The mirrored drive would compensate. And the middle row in the table here, it says RAID 1 with the pink background. Mirroring duplicates data for fault tolerance, but requires twice the disk space, right? So that's RAID 1. Not the best solution, but if it's a small database, it's not so much of a problem. RAID 0 is the bottom example. That's the top row in the table here. RAID 0, striping without parity, high performance, but no fault tolerance. That's the first row of the description. I'll explain what that means. The data is striped. So that means the data, see, block 1 is in the first disk drive, then block 2 is in the second drive 2 over to the right, and it goes back and forth. The first drive, if you look on the left-hand side of RAID 0, it says block 1, 3, 5, and 7, and then the other blocks 2, 4, 6, and 8 are on drive 2. So it's striped across the 2 drives, so it's really quick. If you want to get data out, it could pull from 2 drives at the same time. The system, the CPU, can pull from 2 drives at the same time, so it's very fast. The problem is, if anything fails here, if you lose block 4, you lost data, and you have to go to a backup. You have to restore from a backup. So it's not fault tolerant because it's going to take some time to restore. It's not a quick restore, but it gives you speed. So RAID 1 gives you complete fault tolerance because you have redundancy of your disk drives. RAID 0 gives you striping, which gives you speed, but there's no fault tolerance. Something fails, you can't function until you replace it. RAID 5 is the perfect solution. Striping with parity, and parity means there's a mathematical calculation that's stored in those green disks going across. And basically, if any one of these disks, any one of these blocks loses its data, crashes, or is destroyed somehow, the system can repair that, assuming you'll be notified. You'll pull out the cartridge, the bad block. They're basically sort of like cartridge. You pull it out. You pull out the block, the cartridge. You put in the new cartridge, and the system will automatically rebuild it based on the existing data and the parity calculation. It's pretty impressive mathematics. It'll rebuild that data based on the remaining data and the information in that parity. So it's very fast because it's striped. The data is striped, block 1A, block 1B, block 1C. It's striped across. But the other part of it is you don't have to double the amount of expense. If you have 3 drives, right, and you want to mirror them, you have to buy 3 more. So you're going from 3 to 6. You're doubling the cost. But RAID 5, you're going from 3 to 4. You do have to add 1 more drive to accommodate the space that you need for these green parity blocks within each drive. So essentially there's 4 of them, right? So that's the equivalent of an additional drive. So you need 1 more drive to accommodate this arrangement instead of buying 3 more drives. So it's less expensive, it's fast because it's striped, and it's fault tolerant because of the RAID 5 calculations that are possible with the parity blocks. So those are the 3 sort of common ways to keep your storage up and running and your databases available, for your company. These 3 different kinds of RAID variations. There are other RAID variations, but these are the most common ones. We need to define what an IT incident is, because there are also disasters, and an IT incident is not an IT disaster. It's something that's recoverable in hours. We'll talk about disasters later on in this module. But an incident is an ISP outage, internet service outage, a power outage that's temporary, email server crash, examples here. A ransomware attack that's survivable. Some can be more of a longer duration and bleed into a disaster, but for the most part, ransomware attacks are manageable. A data center flood, a power outage, these are recoverable. They're not IT disasters. When you have an IT disaster, you're out for a day or days. And you need your DR, your disaster recovery plan, to be invoked. So an IT incident needs to be managed. What's the communication plan for the staff and for management? There's a call tree. What kind of outages or incidents need to be reported to the COO or the CFO? You need to have an understanding of what the communication will be like, or if it's an outage that's fairly severe and maybe the better part of the day, do you need external communication? You need to know your vendor contacts and off-hour support if you need to contact the vendor. Obviously have a crash team in IT, know who the application owners are in advance for each application so they could be advised as to how they're being impacted. Equip a war room or a command center, usually a conference room with extra monitors and speaker phones in a way to communicate with the group internally and externally. What are your procedures for an incident? If it's a machine that's infected, air gap it, isolate it, sandbox it so you can look at it, examine it, contact your AV vendor, your antivirus vendor. If it's a zero-day attack, a zero-day attack is an attack that this is the first time it's appeared in any organization, so there is no antivirus signature to identify and destroy it. 0-day means it's new. And those are more problematic, obviously. If there seems to be a crime scene, there's some forensic steps that have to be taken, and there's more about that in the next module in more detail. And update your incident management policy and procedures as things happen. You get better at it, smarter, change your policy and procedures to reflect what you've learned each time. And then there's always the possibility, and we'll talk about this, you might want to use a managed security service provider, an MSSP. This was reviewed in module 10 earlier in the operations and methods module. An MSSP, a management security service provider, like a SecureWorks or an IBM or others, they supplement your security team. So they'll put certain software agents on your critical devices, and they'll remotely help manage your security environment and help you with the response if you have an incident or if you have a virus attack or some sort of malware attack. So they're not so much involved in performance, they're not involved in performance problems, administrative issues with your system. It's more, these are security service providers. So if it's a security issue, you obviously get them involved if you have a contract with an MSSP. There's also a risk assessment that IT departments need to do. And this is for security or for really any issue. But you need to understand the impact on the business when a particular system is either attacked or is down for whatever the reason is. And this is very useful for incident management, and it's critically important for IT disaster recovery planning. So really what this chart does is along the y-axis up and down is the likelihood of the event. So for example, an email outage might have a possibility or unlikely or likely, somewhere in the middle that could happen, that you have an email outage, particularly if it's hosted on premises and not in the cloud. Something like a disaster, an IT data center disaster would be rare. So you would look to see the likelihood of this. And a virus attack might be likely. And then you look to the right, you look at your systems too. If you have what system outage would be likely to occur. And then as you go across the top, you have the consequences: significant to critical, insignificant to critical. The green being insignificant and the critical being red. So if it's very likely, the bottom of the chart and over to the right, a critical consequence, this would be an extreme risk. So this is something that you have to address. Obviously, something that's got a low, it's rare likelihood and insignificant impact on the organization, that would be green. So it's not an exact science, but it's a way to sort of classify your systems. So if they are attacked by a virus or malware, or there's some outage that causes them to be unavailable, you have an understanding of the importance and the likelihood, so you could put a plan together and spend some resources, put dollars to this and other resources to mitigate and be able to manage the higher risk items that may have a higher impact or a higher consequence. So it's a way to help plan. And again, you look at your systems, you look at your technologies, look at the impact by not having it, and look at the likelihood, and try to get a sense for where it would fall in this chart. And then this is not just an IT review. This is done with the business to figure out what the budget should be to mitigate these kinds of risks in terms of likelihood and impactfulness. I thought this Dilbert cartoon was sort of entertaining and certainly appropriate for the subject matter in this lesson. So you might want to take a read. Hope you enjoy it. Break up the lesson a bit. In addition to reviewing your systems and how critical they are to your business and the likelihood of a failure and figuring out what your risk matrix is and how you might mitigate that, you also need to consider the common threat vectors, the paths that threats take to the target. So these are the most common ones, right? The device, computer, laptop, IoT, Internet of Things, gaming systems, routers. Are these devices hardened and is the antivirus updated? Those are the questions there. Email, you have to be concerned about it. Embedded links, attached files. Here's where you want to have security awareness training for your staff. Web browsers, they need to be updated. The software needs to be updated. You need to review any client web applications, for security holes or gaps or vulnerabilities. And wireless hotspot, your WAP, your wireless access points. You should use 802.1x. That ties the WAP, the wireless access point, to a specific port. This was reviewed in the wireless chapter, as well as the type and strength of the antennas, also reviewed in that chapter in terms of understanding, how to design that layout, the antenna strength and type. Telephone, social engineering, for doing reconnaissance. So again, security awareness training needs to include this kind of advice to the employees so they're aware of this technique and how information may be gained about the company through this social engineering task. USB flash drives, lock them down if they're not needed by the staff to prevent malware or a keylogger being inserted. And if it's management and they really need the USB drive for whatever reason, then at least encrypt the data that's being stored on the USB if you cannot lock it down. Regarding physical access, very important. We talked about that. We had a whole chapter on that, a whole lesson on that. Secure access to all the network closets and certainly to the data center. Whenever consultants come into an organization to review a company, a department, or IT for that matter, there's always this triad: people, process, and technology, right? Review the people, their skills, their education, their aptitude for what they're doing, the technologies that you have, and the process. How is your company organized? What are your policies and procedures like? How are they maintained? Are they updated? So that's sort of a high-level view. Now, if you're looking at IT and managing risk, there are specific things that relate to that same people, process, technology triad. So technology, certainly you want to look at the technical controls, the right-hand side of this pie. What are the kinds of hardware and software you're using to secure the systems? You use ISDs, ISPs, what kind of firewalls, are your routers hardened, those kinds of things. On the left-hand side of the process, what does management do to look at the risk, to assess the risk? What are the processes, the policies and procedures? How is your how is your incident management organized? How is the planning for that? How does it react to an issue or an incident? What's your disaster recovery plan like? Is it tested if you have a major data center disaster? And people in the bottom, this is not so much about what the people are, what their skills are in the training. In this context, it's more about, are they keeping to the controls? Are they actually doing the things they need to be doing? The approvals that have to occur, for example, when code is tested and approved and moved from step to step, from development to test to quality control and into production, there should be sign-offs, there should be documentation of the software, there should be backup steps and backup procedures, or back out procedures if there's a problem when you move code into production. So are people following those controls? Are they changing, eliminating the default passwords on new routers that come in from vendors? Is that happening? Are they following the controls? So it's not so much a view of the people themselves in terms of their skills and their ability, but it's, are they following the processes and the procedures that management has put together? So that's a review of the three kinds of controls in general that you want to have for IT: technology, operational, and management controls. Management controls will also be audits, right? Security audits, looking at the files, looking at passwords and access. Are they changing? Is access changing appropriately when staff change positions or when they leave the company? Is their access disabled? Those kinds of audits are part of the management controls as well. So you've looked at your systems, you've reviewed your risks, you've got your critical systems, you have an understanding of what the risks are, you've looked at the controls that you have, technical, operational, and management. And now what else can you do? What else can you do with your risks? Well, there are strategies. So risk avoidance, right? And this is a lot of what IT does for security. Don't participate in high-risk activities. Don't use BitTorrent. Make sure the staff doesn't use that. Lock down the USBs, as we spoke about earlier. That's risk avoidance. Education on security awareness. That's all part of risk avoidance. There's also risk transference. Most companies today need to buy insurance for the internet insurance, not just hurricane events, but they purchase insurance for internet outages. So if you have a busy website and you have sales every day on your website and it's thousands of dollars or millions of dollars, and potentially for some sites like Amazon, they'll have insurance if there's an outage, because they will lose sales if they're down for a half a day or for several hours if you're a very big site. Risk acceptance. There are certain things you just have to accept. I once had a disaster recovery expert review as an external, third party, our DR plan, our disaster recovery planning, and our incident management. And one of the things they pointed out is that our data center was very close to an airport runway. And that's a risk. We just accepted it. We're not going to move the data center. It's an additional risk that it was a general aviation airport as well. A small plane could crash into the building perhaps. Just accept those sort of risks. You may be prone to flood in an area. You might want to move the data center, but if it's very expensive and you have other priorities, you just accept the risk and you mitigate it with other things, other pumps and alerts if there's water in the floors, under the raised floor. Mitigation risks, firewalls, antivirus. How do you mitigate? You're not completely avoiding it. You're not completely eliminating the risk, but you're mitigating it. You're trying to control and minimize the impact because you can't avoid it completely. And then there's deterrence, guards, fences, warning signs, cameras. So these are the ways you can manage risk, sort of categories of techniques or strategies to manage risk. I find that this chart is a good chart to show senior management when you're having a conversation about risk and budget. So obviously, along the y-axis going up on the left, as cost goes up, you're investing more. So maybe you should say investments, not cost. But as you put more cost or investment into security, obviously your risk goes down. You're going to have a lower risk. If your cost is going to be low and your investments are low in security, that's the red dotted line, If you're low on the y-axis, well, then your risk on the x-axis is going to be high. So somewhere there's a happy medium, where you sort of have that earlier slide we just had, whether you're doing risk avoidance or transference or acceptance or mitigation, you have to accept some risks. You can't eliminate them all, or it gets very cost prohibitive. So you hit this sort of equilibrium spot where where the cost meets the cost line meets the risk line, and you accept that level of investment in your security procedures and technologies. So we talked about IT incidences, and we brushed upon the topic of disasters, a full IT disaster, a data center that's destroyed, that can't be you can't recover for days, perhaps, maybe longer. So let's look at that subject now. As you've identified your critical systems, the most important systems to the business, particularly the ones that might have a failure or might have a problem with it. These are going to be systems that you're going to put much higher on your list in your disaster recovery planning, your DR planning. But certainly your critical systems, the ones that, all critical systems you need to obviously put into a high priority category, but particularly the ones that you may feel are more vulnerable. So you need to do a few measurements. What's the recovery time objective? How long will it take to recover from a failure? Is it minutes if you have a hot site? And we talked about this in the physical module, physical security, but we'll talk about this in more detail here. If you have a hot site versus a warm or a cold disaster recovery site, can you recover in minutes, hours, or days? What's the actual time that it'll take to recover these systems? And then you compare that to the next paragraph. What's the objective? What do you need? When do you need these systems to be restored? At what point do you need data and systems to be recovered? Is it minutes, hours, days? Does it match that? If it doesn't, if you have a critical system that might take days or hours to restore, but the company feels it needs to be recovered in minutes, then the recovery time objective is different than the recovery point objective. You need to invest more in it. You need to figure out some way to have the recovery time equal the recovery point objective, the desired objective time. And obviously that affects the budget, the last item here, and you need to reconcile if there is a difference for these systems. So these are standard sort of calculations or concepts that are used when you're figuring your going system by system, looking at your risk and what it means to the business if it's out, and what you need to spend or invest to restore the system in a time that's acceptable for the business operations. We talked about cold, warm, and hot standby disaster recovery sites, and I think it's lesson 2 or module 2 on physical security, or chapter 3 maybe. So we're going to go into a little bit more detail here. So the primary site is this larger circle in the middle of the slide here. And then if we look at the bottom right, a hot standby, a hot site, fault tolerant, 0 downtime. If you look at the bottom, 2 to 4 hours for the recovery point objective, the company's looking for a 2 to 4 hour recovery. And with a hot site, you could do that, maybe even faster. Because you could have a fault over or a switch to that site, sometimes in minutes. So it's fault tolerant, hot site, very expensive. It's a complete redundant copy of your primary site. You can fail over to it. That's the term, fail over to it pretty quickly, and you can meet any recovery point objective, the desired recovery time. Your actual time objective is the same, or better than what they're looking for. As you go up into the warm standby, you have a warm site, and the recovery time, the business may say 8 to 12 hours. You may budget, again, this is a suggestion, 1 day to 2 days for recovery time. Again, it depends on the company and the budget. They may want that recovery point objective, the desired time to recover. They may want that to be the actual time. In that case, this slide, the 1 to 2 day on this orange oval circle here would not be acceptable. But generally speaking, if a company can have a system that's out for half a day, usually if you get it back within a day or so, you're probably okay. Again, depends on budget, depends on the criticality of the system and the business, but that's sort of a suggestion in this slide. And then the cold standby, you'll be down for quite a while. If your primary data center fails, the large circle in the center, and you only have a cold standby, sometimes that's just rented space with sufficient electrical power and sufficient air conditioning, and maybe racks that are installed, empty racks that are just sitting there waiting for servers to be shipped, uncrated, unboxed, it's racked onto the racks, connected to the network. It takes time. So you'll have if you only have a cold standby, you'll be down for days. And it says here, if the recovery point objective, the desired time is a day, you know, you may have to tell them that the budget's only allowing for a cold site, and it may take 4 to 8 days. But again, these are suggestions in terms of the differences between the RPO and the RTO. It really depends on the company, but this is kind of what what people see if you survey what's being delivered for the recovery time versus the objective, the desired time. You do see a difference. It's hard to budget for exactly what everyone wants, and every business division, obviously, and department wants the fastest recovery time possible. So you have to have there's going to be some gap in between the two, as these green, orange, and blue bubbles sort of show between the recovery point objective, the desired time, and the actual time, the RTO. And then in the middle, you have these arrows, which is something you need to consider too. If you're a hot site, on the bottom, continuous data replication. You have to continuously replicate your data, continuously update your software, keep it current with the current primary site. Because if the primary site fails, you have to fail over to this hot site. It has to have the current data and the current software. The warm site, you might have backup data and software, 2 to 4 times a day, several times a day, or a few times a day to keep it fairly current. And on the cold site, maybe you just back the data up there once a day if you have machines there. You may not even have machines there, but you may have a backup site that this site is accessible to. But minimally, you're going to have a daily backup. It may not go to the cold site. It may go to some other site. There are companies that just provide services like this, like Iron Mountain, for example, is a company that you could just back up to their cloud site. Years ago, it was tapes and cartridges. Now you back up to their cloud facility, and they have all your data available whenever your cold site is ready. Or you could have some equipment just for storing, your backups in that cold site if you're not using a company like Iron Mountain, and it's spelled just like it sounds like IRON and the word mountain, Iron Mountain. So you have to look at your cost benefit, how much investment, what's the appetite to accept some of the differences in terms of the desired recovery time or desired recovery objective versus the actual time. But this is a very important compensating control that companies need to consider and fund for the disasters. You could do it on your own, or in the bottom of the slide it says here, option, use a vendor for disaster recovery like SunGuard or IBM, very big vendors in this space that provide facilities for you to help you establish either a hot, warm, or cold site in one of their facilities. So let's get down to IT disaster recovery, or ITDR. So what are the main components of a disaster recovery plan? First of all, you need to have done your risk assessment, right? You need to understand what are the critical systems, what are the impact on the systems if these systems are down. What's your communication plan internally if you have a disaster? Who gets notified? External to IT within the organization. What about external? Stockholders, customers, partners. There needs to be some documented planning in terms of the communication that happens internally and externally. There's also a company I like. It's not the only one, but it's the second bullet here, sendwordnow.com. It's a cloud-based system, and you put all your key contacts in there for your company, their phone number, their personal home number, their cell number, their personal email, their corporate email. And essentially, depending on the message, just by clicking certain radio buttons, you could send messages out. You could even call people's homes or call their phone number, call or text. You have lots of options in terms of how you want to communicate, but it's all preloaded into the system, and you have some pre-settings depending on the situation. But also you can change things on the fly and communicate. So it doesn't matter if your data center is in the state of a disaster. You use this external cloud service to communicate. Your email system could be down. There could be a lot of outages, but you do have a way to communicate through a cloud to phones and emails, whether they're personal or corporate numbers. Obviously, identify the critical systems and components, set a priority sequence. So what's the sequence with which you'll bring systems back up? Networks, email, those will probably be the first two. And then depending on the company, whatever your core, a business system is to support, either a call center perhaps, or if you're processing claims like an insurance company, that would be critical to get up as soon as possible. But you have to set a priority. People can't work on everything at the same time when they're restoring systems. You have to have some priority. And the next bullet is determine and document the detailed disaster recovery steps. And of course, I put a note here, store off-site. Your disaster recovery plan must be stored off-site in GoDaddy or some other cloud location, because if your data center is destroyed and you have it documented electronically, you can't get to it. Often companies will print out this documentation as well, and it'll be in the homes of the senior executives and the senior IT people. Should there be an electrical outage, you can't even contact GoDaddy or some other off-site website to access your plans. You have a hard copy in your home. So that would be, the worst case scenario where there's an electrical outage, in the region. But you do need to store them off-site, obviously, not just, in the data center or in the building where your corporate headquarters is located. And then what they call tabletop exercises, mock disasters. So you have your key people in a large conference room and spend a day or two and go through all of the steps, review your disaster recovery plan with that group of individuals to ensure that they understand what the steps are and what to do in the event of a disaster where the data center is completely disabled. And then test the plan, the second to last bullet here, annually. Actually, if you have a warm site, or usually people don't have a completely cold site, they'll have something there, some sort of service that they can connect to just to make sure communication works. So whatever you have, whether you have a hot site, a warm site or a cold site, you should have some sort of test annually to see if you could fail over to that other site and to see what's running, and to have your IT staff there going through the steps of restoring systems and getting data up, making sure the data is totally restored in the software, and to bring up the servers in a way that can support the business. So you have to test that plan, and then the last bullet, update your plan, ensure there's compatibility with the incident management plan as far as the staffing and who does what. Usually when staff changes, senior people or management people change roles, both of these plans are going to be impacted, the DR plan and the incident management plan. But obviously you need to keep these current so that they have the right people, the phone numbers and the contacts are all in these plans accurately. IT disaster recovery is one component of a larger plan called a Business Continuity Recovery Plan, BCRP. There needs to be somebody in charge of BCRP. Sometimes it's the Chief Information Officer in IT, because IT is accustomed to planning for disasters, and they have a plan for their IT data center disaster. So it's not too uncommon for the company to ask the Chief Information Officer to also help manage the full Business Continuity Recovery Plan, which incorporates all problems with the company. So the data center could be up and running, but let's say the main corporate headquarters or a large call center, the building is closed, the fire marshal hasn't reopened it, no one can get to work, or there's some contagion going on, or some chemical spill or disaster, and OSHA closes the building. Your systems are running, but the people can't get in the building. So what's your plan for that? So I've had responsibility for BCRP, again, being the CIO and having a DR plan. I was asked to work with, and you do have to work with many people in the company, usually HR and this chief operating officer and the senior vice president for human resources, HR, to work together to figure out how you're going to accomplish this. And you need a budget. And I had a couple of full-time people that helped me with this, because it's a lot of work to maintain a plan for the entire company and not just your IT plan. So we'll take a look at how this works, but essentially there's a little list here, if there's some problem with a pandemic as well, which I always talked about, but never thought I'd live through a pandemic and staff can't get to work perhaps. I once had someone with an infectious disease, AIDS actually, vomit in the data center in the middle of the night, and I was afraid that, and this was a medical center, I was afraid that the infection control department and the physician might quarantine my data center and not allow staff to work there in the morning. But it sort of got cleaned up, by the staff. I mean, they were really great people. and then the infection control department to their cleaning, and they were able to open the data center and allow people in the morning to work. But had they quarantined it for the day, we would have had some serious problems with not being able to do certain functions in the data center if no one was allowed in it. So these are things that the system is up and running, the data center is there, but there are other things. There could be strikes, there could be a riot, there could be other issues that interrupt your business. And these are things that you have to consider. Again, you can't eliminate all the risks, but you need to at least plan for it and have some mitigating steps and some concept for how you would communicate internally and externally, and what are the things you might do in one of these if one of these incidents should happen, or a hurricane and power's knocked out, or the systems are up and running but the buildings are flooded or damaged. These are different scenarios, and like I say, people, not just pandemics, but there are labor strikes, there are other issues. There could be an active shooter in the building. We had a company come in and help us look at that. What are the steps that you would do for an active shooter? These are all business continuity concepts to keep a business running. And of course, the one that IT worries about is the data center itself. But that's just one component. The data center recovery plan is one component of the BCRP plan, the business continuity recovery plan. And this graphic has a bit of detail that's not necessary really, but I think it drives home the point with this pyramid, that towards the bottom of the pyramid on the right, the circle says disaster recovery plan. That is a subcomponent of the business continuity plan. It's just one of the things that has to be considered. So the aqua, greenish blue color at the bottom of the pyramid are all the IT concerns and considerations for a disaster recovery plan. And as you go up the pyramid here, you have different kinds of policies and strategies for keeping the company up and running, even if the system is up and running, but the people can't work in the building, or there are other issues that prevent the business from running. And of course, in the middle here, you see some gray areas that talk about validation testing. You have to validate your plans and test them, whether they're desktop mock disasters or whether they're tests, an actual real test of the backup site. Once a year, you need to do that. And there's sort of some generic terms in the middle here. Risk management and business continuity plans refers to what are the other things that you would have to consider: pandemic, a strike, a riot, a building that's blocked from access through a strike or through a contagion, or a fire marshal that closed the building. So this is sort of gives you a concept again to reinstate how BCRP is a much broader topic than just the IT disaster recovery plan. So this circle here shows a cycle of BCRP corporate-wide planning. Again, it's not just IT, it's for the entire company. If you look at the left-hand side, there's a note here: IT needs to partner, if they're responsible for BCRP, needs to partner with the Chief Operating Officer, the Corporate Communications Department, HR, and other significant departments that are impacted. But someone needs to own BCRP. Someone needs to be responsible for ensuring that the plan exists and that it's kept to date and it's available. So here on the circle to the right, there's identify the risks. We talked about that. Again, these are all risks, not just IT risks. Analyze the business impact. What's the impact if one of these critical components to keeping the business running is missing? What's the strategy and the plan? That's number 3. And number 4, measure, test, train, and maintain it, and make sure it's current, that reflects the current environment that the company's in, and any other new issues that might come up. Sometimes companies are not unionized and they become unionized, and now that's another concern of a strike, and you need to update your plan. This is just one slide about security forensics. If there's a crime, or there's some concern that a crime has occurred, or there's knowledge that a crime has occurred, these are the steps, these are the things you want to consider. We have another lesson just on forensics, but real quickly, the order of data volatility. So for example, data that's in the RAM would be lost if you shut a computer off. So you don't shut computers off because you want to be able to examine the memory, the random access memory, or any of the volatile data, temporary files, those kinds of things. Network traffic and logs need to be reviewed and retained. Trace route could be used to trace through the network to see where IP addresses may have come from. It's a certain network command, trace route. And then what they do is they copy the image of any system that they believe was involved with a crime. So you hash the system, which means you actually take sort of as we talked about hashes earlier, you take a sort of a fingerprint of the system. So, and you make a copy of it. So you've got a hash total of all the characters. Every single bit and byte is hashed and encrypted into a fingerprint to identify that system. Then you'd make a copy of the system, and you do your work on that, and you hash that as well to ensure that you hash it before you do any work to it to ensure you have a full copy. The hashes match, you have a full copy, and now you do work on the copy. When you do your forensic analysis, you don't do work on the actual device that was involved with the crime or the actual equipment. If people photograph the scene, interview witnesses, there should be a chain of custody for any of the machines that were infected, any of the machines that were suspected to be part of a crime. A chain of custody means there should be a document that explains, who took the hash, who took the machine, who copied it, who took this machine off the site and took it to a secured area and locked it in a cage, in a storage area. And you need to know who's had possession of that machine at all times and where it's stored. And then if there's any possibility for artificial intelligence analysis, that happens, of course, sometimes depending on the vendor that you get involved, and ensure to notify your local FBI office if there really is a crime that needs to be investigated. This concludes this module on planning, incident management, and business continuity. So be careful out there, folks.